Okay, boss. Forgot. Okay, boss. Yesterday online they missed this topic, logging table. See, we've been creating different settings for the tables. So then there's an option called no logging. So generally, when you see in the HANA architecture, you could observe that whenever you're creating an entry into these tables, it does create a log. Through logger, it does create a log in the log volume. That's how it does maintain the data persistency, right? But when it comes to when you define a table with say no logging, it does not maintain any logs for this table at all. So the data will be stored only into main memory bus. The physical memory reaches 80% of the main utilization, then the data in this table is been truncated. After, if you specify some timing, after this time, and when the percentage of the physical memory is used more than 80% of it, then the data in this table will be truncated. That is what I mean as no logging. Because we cannot see this effect until I use this memory until 80%. That's the only option. Hello?
Unmuted. Muted.
Hello? 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 వాళ్ళకి వినిపిస్తుందంట. హలో? Okay. So I'm saying when you create a table with no logging, whenever you have the data inserts or updates onto the table, it only updates into main memory, but does not do it, capture any logs, and logger does not put into the log volume. So there's no logging is done on the table, and the data in this table is stored until the memory is utilized until 80%. Once it crosses 80%, the data in this table will be truncated. That is called as no logging option. And even while creating this table within the UI, say for example, you create new table. If you go to this further properties, you have the option here. What is it? No log. So even with the UI, when you're creating it, you have the option as setting it as no logging also. That's fine. Okay, boss. Next, merging concept. Very, very important, but you don't do anything on it, but you need to understand the concept, what is happening in the backend. Yeah. See, you'll find this when you go to Google and say type in SAP HANA Delta Merge, get to this PDF document. You just go through on that PDF, but I'll just get you this. Look at this. So when you say column store table, it would basically have delta store and what? Main store. And when you perform the read operation, it does read the data from main as well as delta both. And when you do write onto the table, it all only updates into what? Delta store. And at later point of time, we have to move the data from delta store to the main store. That is what we do when you perform delta merge. When you perform the process called delta merge, I don't know. Hello? Hello? Okay. When you do write, when you perform write operations, it does do write data to delta table. And when you do delta merge operation, it does move the data from delta store to the main store table. Because delta store is more optimized for writing, which is not compressed. And main store is more optimized for reading. Okay, so since delta is optimized for writing, all your write operations take place to delta store. And when you perform delta merge operation, it does move data from delta store to main store. Okay, boss? Okay, and if you get it clearly what happens when it is happening, like say, okay, so when delta merge is happening, is it locking those tables? Are those tables or something? Now look at this process. If you get into depth of how what happens during, now look at this. Let's say now I've created a column store table, which is in main. It does have main one and let's say delta one. Initially, let's say I just created a column store table. It has got main table, delta table. And I'm referring this as main one and delta one. Okay. Let's say I inserted 5 records and I've done the merge. So all the 5 records should be in which table now? Let's say main one. Let us assume it has already been merged and I've got 5 records in the main table. And again, now I'm writing some 3 records. Out of 3, 1 is committed transaction, 2 are not committed yet. 2 are not committed yet. So totally there are 5 transactions in main table and 3 in delta. Out of 3, 1 is committed and 2 are not been committed. So at this point of, let's say I've not yet done any merging. When I'm doing the reporting, it does read from main and delta, union of it. When you're writing, it still writes to delta bus, right? So now we are referring it as main one and delta one bus, okay? Let's say now you say perform delta merge. Perform delta merge. Now what happens? Now look at this. During operation, okay, it does take all the transactions from main one, okay, all the committed transactions which are already there in main one and puts into what? Another table called main two. Don't say table, it's a location, okay? It puts into a main two. And you have delta, right? From delta, all the committed transactions pushes to what? Main two. All uncommitted transactions, it pushes to delta two. What are the transactions we had in main one, it pushes to main two. And from delta one, all the committed transactions will go to what? Main two. Uncommitted transactions of delta one will go to delta two. And immediately when you're writing, even during merging process, if you're writing data, it will be using what? Delta 2 for writing. You don't have to wait until the merging is happening. Immediately delta 2 is created and you can still be able to cut, but it goes into what? Delta 2 store. But even during this process, your read operations on what? Main one, delta 1 for committed transactions in delta and uncommitted transactions from what? Delta. So even during my merging process, if you're writing records, you can still be able to access them for reading also. Because I'm still referring data from main one, delta 1 and delta 2. And once the merging is done, all the data has been moved now to what? Main 2 and delta 2. And the main 2 and delta 2 will be active now. And main 1, delta 1 and the main 1 will be freed up. Like this, it keeps formulating the new main, new delta, new main, new delta. So for example, I've got 5 transactions in the main table, okay? And let's say delta has got 3 transactions. Out of 3, 1 is committed and 2 have not been committed transactions. Okay? So when you do reporting, now you will still be able to get those 8 records now. Okay? Let's say because it does read from main and delta bus. Let's say now you trigger the delta merge process. Even, okay, let's say you're triggering delta merge. What does the system do? All the data from main 1 is pushed on to what? Main 2. And all the committed transactions of delta 1 is also pushed on to main 2. And the uncommitted transactions of delta 1 is moved on to delta 2. Okay, and then main 2 and delta 2 becomes active, and the main 1 delta 1 is freed up now again. Like this, it keeps formulating new main, new delta every time you perform a merging. Where we already done the merging, and already merging, so there is some data already in main table. Assume means you have saved the transaction. You have saved the transaction. You have not yet commit means you have saved it. That's okay, boss. So the point here is, even during my merge operation, can I still read data, boss? Still, I've got it, but only during the time when it is switching delta from delta 1 to delta 2. That is the time it is enqueued. It's very small point of time, so you don't have to really worry about that. So with this concept, that is what delta merge is about. Yeah, what is it? I'll come. Clear on this now? So now next one more point you need to know is, let's say I have a table, and there's a concept called partitioning of a table. Like how do we partition cube? We can also partition table. Let's say I have a table and I've partitioned 4 tables. So I've did 4 partitions on a table. When you say perform merge, okay, it does perform merging for each partition separately. Each partition itself is considered as a separate table. Partition 1 will have main 1, delta 1. Partition 2 will have main 1, delta 1. Partition 3 will have main 1, delta 1. And partition 4 also will have main 1, delta 1. Okay. When you say delta, when you perform delta merge, it does perform delta merging only on the partition where there's been new changes been happened, or new records have been posted into the table. Getting this? Let's say I've got 4 partitions first. Each partition will have a separate merge operation first. Each partition will have its own main table, delta table. Okay. So when you perform delta merge on a table, it does perform merging only on the partition which has got a reflection with new data in it. Otherwise, no. If there's some new transactions have come in, only then the delta merge is triggered for that partition. Otherwise, no. That's second important. So what they say is, suppose I have a single table with no partitions with huge data in it. Let's say I've got 1 million already, 1 million records where merging was already done. Now I add 2 more records. So I'm a processing delta merging on the entire set first, because there's no partitions now. Let's say I've got 4 partitions. Already, let's say for 1 million records, merging was done, and I moved this into partition 1. Now the 2 new records, what you added, let's say they come into partition number 4. And when you say merging, will it trigger merging only for partition number 4 or all the partitions first? Only 4. Then how many records does it move from main to delta or main to another main? 2 records. So when you do partitioning on a table, will it speed up the merging operation? When you say speed up, it does only perform merging on the partition where there's been new reflections of the. Clear this? Now question is, he says, what is the advantage of doing merging? What is that merging doing? It moves from delta table to main table. First of all, my question: why should we have delta table or delta storage? Because we wanted a column store to improve the reading operation, but the problem is it does affect your write operations. To speed up the write operations, we have come up with the concept of having delta and main, but there should be always a mechanism of pushing data from delta to main table back. You getting what I'm saying? See, delta merge, we are not doing it for improving some performance. The concept is, in a column store table, it is good for reading, but bad for writing. To overcome this problem, SAP came up with the concept of delta and main store, where delta is uncompressed, main is more compressed. So what we do when you do delta merge, it is moving from delta store to what? Main store, and you are basically compressing the data. That is one advantage you get, but ultimately it's an operation. We are not doing it for some performance, but ultimately you get a performance because data from delta is moved to main, then the data is compressed. When the data from delta is moved to main, the data is compressed. That is advantage you get. But if you ask me why am I doing this, because of column store tables. Because in every column store table, it must have delta and main, because to handle the write operations. And to push data from delta to main, I have to perform delta merge. only for column store table it does perform merging. See, you don't create main table, delta table first. You just create column store table. Internally, it left two memory locations. One is called as main memory location. One is called as delta memory location. In main memory location, the data will be more compressed and stored. In delta memory location, the data is not compressed. When you write, it does store in for temporary purpose. It does store in the delta storage memory. Then when you trigger merging, it moves records from delta memory to main memory. You don't, these are not like two tables. I'm not creating like two tables. These are like two storages of the same table in the back. Okay. And one very, very important point to be noted is, let's say I have a table and you're doing huge inserting data into the table. At that point of time, if you do merging, it will affect the data loading process. So I have a table, you're trying to fill in lots of records into it. At the same time, if you trigger merging, it will affect your loading performance. Say, I have a cube. See, for cube, DSO, everything, it's a column store table in the backend. While loading data into the cube or while loading data into the DSO, if you perform merge, it will affect your loading performance. So what SAP says, whenever there's been huge loading happening, finish off your data loads, then trigger merging. Don't trigger merging during the loading process. You're okay? Uh-huh. See, okay. See, this is a column store table, right? See, the same table has got some memory allocated for main storage, and what is this here? Delta storage. It's not two different tables. It's the same table which allocates certain memory as what? Main, some memory as what? Some memory location as delta. And the delta memory locations are not compressed record. They just stored record by record like that. And for the main, it's more compressed. When I say compressed, you remember, if I have column values, like it only maintains distinct values only. If I have 10 million records with regions like south, north, east, and west, it does only store only 4 times instead of storing 10 million times. That is compressed mode in main. In delta, it is not compressed like that. So when you perform write operation, it does go into what? Delta. Then when you perform merging, it takes this data and pushes it to what? Main. Then the data is compressed. Okay, and why am I doing all this? Because I need to improve performance of a write operations on column store table. And I'll have to perform merging only after the complete data loads are done. So while inserts and merging should not be done at a time, it will affect your loading performance. Because all your targets like cube, DSO will all use column store tables in the backend. So when you're doing data loads to this, merging should not be done at that point. See, delta and main are not tables. They're only memory locations. But for you to understand, I'm just referring it as main table, delta table. But it's all two memory locations, storages. That's it. Yeah. 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 Why? Rotating error. What is it? Means enqueuing, you're saying. And see, you're saying you're inserting and reading also you're doing on that. So what is the problem? See, for reading, the tables are not logged. So the tables, when you read the table, it is not enqueued. What is the problem in writing and reading on the same table? If multiple writes are happening, then what happens? After one write, the next write happens. But when you read and write, it can go on simultaneously on a single table because reading does not enqueue the table at all. Now look at this. So when you basically right click on this table, you have the option as perform delta merge. When you right click on this table, you have an option called perform delta merge. Okay. Now look at this. let's say I create some tables. Sure. Hmm. Okay. Let me just create table normal with UI. Column store, EMP number, EMP. Okay, that's a simple table, and I've done nothing. Okay. Now, if you look at this definition of the table, what I've created, export SQL, column store table, so and so, and then primary keys. Okay. Now, what I'll do, and by now I'll say switch on the auto merge. This is like normal creating table. Now, I'm just what I'm doing is I'm just creating table with say auto merge. There are different types of merge. The first one we're dealing with is auto merge. So I've created a table with auto merge as a concept because I want this table to be performed with auto merge. Auto merge is enabled on it. So when you say, okay, let me just create this. So now I should have the table EMP merge. So this is my table. Open the definition of the table. You have main and delta, both are blank now, nothing else. So when you enable the table with auto merge, okay, when you go to the system administration, you'll find there is some process running in called merge dogs. If you go to configuration, in the index server, you'll have a process called merge dog, which is running in the backend as a process. Okay. Now, when you say auto merge, system has to trigger the merging automatically. So who does trigger it? Now you'll have something called merge dog, is a process in the backend which identifies the column store tables on which the merging should be done, and then it does trigger the delta merge. If it is what? Auto merge. If it is auto merge, if auto merge is enabled on a table, you'll have a process called merge dog, which will be scanning all the tables for which the auto merge is enabled. And whenever the decision is satisfied, does trigger the auto merging process. Now, which decision it is? Look at this. There's something called auto merge decision function here. Now, look at this. Right click and say change and try to see this. There is some decision function which is given here. When any of this condition is satisfied, it will trigger the delta merge. Who will trigger? Merge dog. If you enable auto merge on a table, the merging is done automatically by merge dog whenever this condition is satisfied, which is what? Auto merge decision function. What criteria between, like say, for example, DCC greater than 100 and DCC delta cell count. In the delta storage, if the number of cell count is greater than 100, do this. And you'll have different strategies on this. And there'll be some meaning on this part. When this condition is satisfied, it does trigger the delta merge in the system. So what I do now is, I'm inserting so I'm just inserting this record. And if you see this, now main and delta are blank. Okay. If you're inserting this record, now where is my data returned to majorly? Just increase my delta storage, not the main. Eh? Mhm. I'm inserting more. Okay. Still, it is increasing only size of delta. There will be some case where it has to identify sizing, then we're not triggering this auto merge. System should trigger this. Mm-hmm. Reach callable. You can change that. Even now it doesn't work, I'll try to change it. So I've given it as DMS means delta memory size. So if delta memory size is greater than 300, it has triggered this. Okay. So now KB lo irukku. And it will be fat load. one second. There's a logic here. Logical. This is one condition. Just putting and with this, or this one. So there's a condition within this. Here it is ending all the conditions. And let's say DMS greater than, so that's it. Only one condition, yes. Okay, I'll perform it manually. Right click, I'll save it. Okay. Perform. Actually, it has to be done automatically by the system when the condition is satisfied. I've done that. Then look at this. So now what's happening? It is moved data from delta to what? Instead of me triggering it, system should do that automatically when the condition reaches that satisfaction. Okay? No, we don't schedule it. If it is automatic, system will be taking care of doing it. Manual, I'll come. Then there's something called smart merge bus. When you say smart merge, it's you are going to trigger the smart merge. System will not identify it automatically. In that case, you will have to explicitly trigger the smart merge through SQL, or if it is BW with HANA, you'll have a process new process type called delta merge. Then through that you trigger it. Even if you trigger smart merge, again smart merge also will have some decision function. Only when this is satisfied, it does trigger the smart merge. Otherwise, no. Auto merge system will trigger the merging automatically by the system, and smart merge is what triggered by you. So if you are triggering smart merge through SQL command or some BW process type in process chain, it will perform only if this condition is satisfied. Otherwise, again, smart merge also will have a separate destination function. I'll put that next slide. Okay. Like this, you'll have auto merge and smart merge are different types of merges. But if you go down, see there's something called auto merge, which is this auto merge, and there's something called critical merge. Say you have switched off the merging. Let's say you switched off the merging auto merge on the table. When you switch off the auto merge on the table, system will not take care of merging. You should do the merging, and you never done the merging at all. If it reaches some extreme case, system will trigger that merging automatically. That is called as critical merge. Even though auto merge is switched off and you never perform the merging, the delta size is being peaks, then system will take care about merging. That is called as critical merge. So auto merge and critical merge both will be taken care by automatic system processes, which is called merge dog. Okay. And there are other merges like hard, force, smart merge, and memory merge. Again, when you say smart merge, it's an event which is triggered by the user or from the SQL command or through process type in process chains. When you do this, even then it will perform merging only if the condition is satisfied for what? Smart merge decision function. Now when I say hard merge, when it trigger merging, there should be no decision function should be checked. It has to do merging. Now when I say right click perform delta merge, that was hard merge. No condition was checked. Straight away I'm performing the merging. Don't check any condition. Straight away perform the merging. I can write a SQL statement, perform delta merge and delta merge on it. And the right click go to perform delta merge on that. That was actually hard merge. And then there's something called forced merge. Okay. When I say forced merge, you trigger the merging. Let's say because of resource not available, let's say this process kept waiting. But when I say forced merge, Irrespective whether my server is really pressurized, it has to finish my merging. Hard ante una trigger it will perform only if the server is free. But when I say forced, irrespective whether my server is free or not, it has to do my merging. That is called forced merge. Okay. And when I say memory merge, memory merging will do only in main memory. When it does not put the data into disk. Generally, whenever you do merging, it updates data into the disk also. But when you say memory merge, it does not update the data into main memory. It updates into the disk. It does perform merging only in main memory only. So, like if you go down, you can just read through all this. But there are different types of merging. What we do is in BW, we would be using smart merge for cube and DSOs also. And the process chain loop will, after loading data into cubes or DSOs, we'll be using smart merge. If you go down, see, for PAC it does use what? Smart merge. For master data it is what? Auto merge. And for unoptimized DSO again it does use smart merge. When we trigger it runs it, that is again smart merge. Advanced DSO smart merge again. Right optimized DSO is also smart merge again. Okay, only for master data it is what? Auto merge. But while loading data, don't do the merging. So what we do? All the tables relevant to cube or DSOs, the auto merge will be switched off, so that system will not trigger the merging. After the DTBs are all run, we would trigger the merging process from the process chain. See, like you'll have a process called what? Trigger delta merge, which is actually when you trigger and then it triggers it, that is called smart merge. And thus use a smart merge decision function, then triggers or not depends on the function. Like this, we'll have different types of merging. Okay. Yeah. Yeah. Peaks at the extreme on it. These actually we have some like one table can hold 2 terabytes of data. So your delta store, if the delta store reaches 2 terabytes of size, then the critical merge comes in. Otherwise, no. Okay. And even if it triggers, nothing happens. Your loading will go, the performance of the load will go down. That's it. It does not disturb any data. Only thing is the performance of the load will go down. That's it. Even critical merge triggers in, your performance of data loading to the queue will go down, but ultimately data gets loaded. No issues. Okay. But here I'm not doing any merging. Just by using this, whether I'm just switching off the auto merge. When I say no auto merge, what I'm doing, I'm switching off the auto merge. And if you say auto merge, if I just use the keyword auto merge, then what? I'm enabling auto merge. That's it. And we will see when triggering, when you see this data manipulation statements, we'll see how to do smart merge, how to do hard merge, all this. Yeah. There will be something like perform delta merge with parameters as smart merge on, and it becomes what? Smart merge. That's it. But don't worry about triggering merging, no. Just enabling the table for auto merge or no. If I say no auto merge, what? We are switching off the auto merge on the table. And when I say auto merge, just without no, then it is what? Enabling auto merge on the table. Then if you enable auto merge, what happens? Merge will be triggering the delta merge process automatically based on the decision function of delta merge function. That's it. And if you say no, the auto merge is switched off. You have to explicitly trigger the merge process through either SQL command or some, if it is BW on HANA, you have to trigger through what? Process chain process. This is nothing to do with the performance. It is only because column store has to move data from delta store to main, because delta is uncompressed and it is not optimized for reading. So you have to keep pushing data into main. As long as the data does not come into main, the read performance will be slow because the delta is not optimized for reading. It is only optimized for writing. In any system, it is needed. But for BW, we can explicitly trigger that process. Because when you say BW on HANA, BW will have something called process chains. It will have a specific process called delta merge. When you do this, it is triggering merging in the back. Next is unload priority. Now we have a concept called loading and unloading. How frequently merging will be done? You can do after every data loading on the target, you trigger merging. But it does it actually perform the merging or not depends on the smart merge decision function. Okay. Next is unload priority bus. Yeah. 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 That's what I'm saying. Even if the delta merge happens during write operations, the table is logged only for very short durations of when you're switching from delta 1 to delta 2. Otherwise, you're not logged. So you can still continue writing out. The load and unload bus. When you say load the tables, you're loading from disk to main memory, and when you say unload, you're unloading tables back from main memory, out pushing out of memory out of. So when you right click on the table, you still have the options like load into main memory and unload from main memory. Unload means you're removing it from main memory at all. Load means from the disk you're loading it back to main memory. That is like operations. No, but what I'm doing here is this is not we're not operating the table. We're not manipulating the table. When you say unload priority, while creating the table itself, we can specify something called unload priority. When the number we can have priority from 0 to 9 bus. Lower the number, it means it holds the table back in main memory. And higher the number, if there's some constraints on the space, it pushes them out from the main memory. Let's say now I've got lots of tables into main memory bus. Now it has to free the space out. Like it does use some algorithms and pushes some it has to free the space. So which tables are pushed out? The tables with highest unload priority is what? 9 will be pushed out first. Then still next space is required. Again, the tables with unload priority of 8 are pushed out. Next 7, next 6, next. So lower the number, it means it wants to hold it back in main memory bus. And higher the number, it can unload the data from main memory when the memory has been filled up. That is why while creating table, you can specify this unload priority, whether it is 0 or to 9. When it says 0, never unload it. If it is 9, if the space is, the table will be unloaded first. The tables with unload priority as 9 will be unloaded first to free up the space. By default, it is 5. By default, it takes unload priority as 5. Yeah? So you just say create table so and so, then you will say unload priority 0. So this table will be never be unloaded because I'm saying 0. Right? If required, I'll let manually unload it. Don't worry. But if you consider the table to be hot, really used for reporting, you'll always have the 0 and I'm not loaded into main memory now. I've configured table with unload priority 0. If this table is loaded, then it will never be unloaded until the memory is completely, other tables have been unloaded. Now the table is not in main memory bus. As long as I say load. Load, unload operations are different. This is only a setting on the table with unload priority. When the table is loaded into main memory, it can be unloaded only when the priority is high. Like the tables with priority 9 will be unloaded first when it needs to free up the space. And it slowly comes down. When I create a table, is it data definition or not? This is not like manipulation. Okay. When I create a table with unload priority, it means I'm not asking the system to load. I'm saying the unload priority of this table is 0. That's it. So once this when the table is loaded to main memory, do not unload it until you unload other set of tables. This is the critical table. I want it to be in main memory when it gets loaded. It unload priority 0 పెట్టి టేబుల్ క్రియేట్ చేయడం వల్ల టేబుల్ మెయిన్ మెమరీకి రాదు ఇప్పుడు. ఎప్పుడు వస్తుంది? నేను ఎప్పుడైతే లోడ్ అంటానో అప్పుడు వస్తుంది అన్నట్టు, అందరికి రాదు. వచ్చిన తర్వాత పోదు, తొందరగా పోదు. ఎప్పుడు టేబుల్స్ విత్ నంబర్ 9, 8 అన్ని పోయిన తర్వాత లాస్ట్ లో 0 పోతాయి. ఓకే, నౌ ఇట్ ఇస్ నాట్ లోడింగ్. Again, setting up the priority not to unload it. That's it. And higher the number, it has to unload it immediately. Then there's something called partitioning on the table. How do we create partitions? Like, do we create partitions on a cube? Month-wise, fiscal. Same way, you can also do partitions on a table also. And we can do partitions in three ways. One is hash, range, and round robin. Hash partitioning, range partitioning, and round robin. Say, when you say hash, say, let's say I've got certain column like employee ID, some primary key column. Hash partitioning is done on primary key column, and you would like equally distribute it across multiple servers. Let's say I've got 4 servers, 4 index servers, and I would like this based on the employee numbers, equally distribute the data into multiple servers across multiple servers. Then I can go with hash partition. నాకు డైలాగ్ ఇన్స్టెన్స్ ఉన్నాయి 4 ఉన్నాయండి సర్వర్స్, and I would like distribute this table content into 4 partitions or 4 partitions, and each partition into different servers. Then I can go with hash partition. Okay, equal. Then there's something, and you don't specify anything, number range or something. Based on the content of data, it's automatically split up. Then there's something called range partitioning. This is where you do where you specify where date is so and so, year is so and so. You can specify some conditions you want. Say partition number 1 where year is equal to 2013, partition number 2 so and so. You can specify interval or range, anything you can specify. Then round robin is similar to your hash, but here it does not distribute the data equally. What it does is, look at this. You load data into the table. So you bring some data into the table, and I'll take this data into separate partition. And what are the new data comes in? It comes into another new partition. అంటే బేసికల్గా నాకు ఓల్డ్ డేటాని న్యూ డేటాని డిఫరెన్షియేట్ చేసుకుంటా ఉండాలి. సో ఐవ్ గాట్ సమ్ న్యూ డేటా now loaded. Then all the new data what we load into this table should come into partition number 1. After I perform some operation, it has to go into a partition number 4 or partition number 3 something. When you want to control those kind of operations, then you go with round robin partitions. For example, if you look at your info cube in BW, have a column store table with 4 partitions with round robin only. So it will have 1, 2, 3, and 4 bus. When you load data into the cube, it actually gets loaded into partition number 1. After you say compress the cube, when you have compression concept, then it does move data from partition number 1 to partition number 4. Again, if you load new set of data, again new set of data will come into partition number 1. Again, when you compress, again partition number 1 data will go to partition number 4. Basically, you want to distribute the size of the table based on the new data being loaded and the old data. You go with round robin part. That is not equal distribution. Hash partition is equal, but in round robin, I would like distribute like new data coming in, old data coming in. I would like separate those records based on the partition. Then you go with both round robin. Koth records, path records are differentiate jello when partitioning. Then you go with both round robin partition. అంటే నీ అప్లికేషన్ స్పెసిఫిక్ గా లాజిక్ ని బట్టి ఈ డేటా ఈ పార్టీషన్ అది ఆ డేటా అట్లా నువ్వు కంట్రోల్ చేసుకోవాలనుకుంటే యూ కెన్ యూజ్ రౌండ్ రాబిన్ పార్టీషన్. And partition is very, very important. When if I say the maximum size of a table could be 2 terabytes, if you need to handle more than that, then it comes like each partition can have 2 terabytes. So if you want to hold 10 terabytes of data, then I can create 5 partitions, and each partition can get up to 2 TB. And the one table size is equal to nothing but one partition is itself is like considered as a separate table. And creating partitions will also improve the performance for your delta merging also. Because delta merge will be performed only on the partition where there is got new data loaded. So now, how do you create hash partitioning? This is all. But here I don't have multiple servers. If you see the administration here, in the landscape, I have only one index server. Yeah. This is how you use create so and so table. And what is my primary key in this? Employed. And hash partition is always created on the primary key column. Yeah? So partition by hash, and on which column it is? Employee ID. And how many partitions I want? 4. But instead of specifying 4, for example, in real time, if you have multiple servers, based on the number of servers, I want the determine number of partitions, I can say. So something like function like server number function, which will determine number of servers automatically. So if I create this table, sorry. So I should have a new table now. EMP hash. If you open the definition of this table, if you go to runtime information, you will see this partition specification is what? Hash 4 number of, and based on what? Employee ID. Here, if you expand this, you will get to see partition number 1, 2, 3, and 4. It has moved like one row, one record here, 3. It does distribute it by default. We cannot control. System will take care of distributing the records automatically. This is hash partitioning. But instead of writing with SQL, I can also create partition with UI also. Okay? For example, I have this table, right? What is the table? EMP, and there's no partition yet. I would like to partition on, let's say, EMP number. So what I can do, look at this. You right click on this folder tables, you get option as what? What is? Show table distribution, or when you right click on the schema, you get option as show table distribution. Either way you can do, and I'm going on this. This is my EMP table, yeah. Okay. This is a table I wanted to configure, so right click and show it. Partition table. What partitioning you want to hash partitioning or range partitioning? I'll say what? Hash partitioning. And if you say number of partitions equal number of hosts, not going to OT host server, so it creates only one, but I will go with what? Not the number, I would create, let's say, 5 partitions I want. Okay? That's so I want hash partitioning and number of partitions is 5. Next will ask you, so it is only allowing me to select employee number only. There are other columns in the table, but only primary key is allowed for hash part. This is a column on which the partition must be created. So yes. That's it. It is as good as altering your table by creating partitions here. Now if I see, yeah, both have to be considered. So if you go, so hash by number and you see 5 partitions. Like this, you can go with hash partitioning. And there's something called range partitioning in this. When I say range partitioning, you're just creating on where my month is so and so, or between. You can go with between or equal to anything you can specify. Now look at this. I'm just creating this table. This is where it starts now. Till here it's common. You're just specifying all the. In this case, my order ID and order date both are primary key. And from here, this is till here the table setting is done. Now I'm starting, let's say, partition by range, using which column? Order date. And I want one partition as what? Between 1st of Jan 2015 till 1st of June. And then there's one more partition value which is explicitly equivalent to what? 15th July 2015. Equal to bit between bit range anyway is possible. And there's one more partition, others. SU means what? Anything which which does not fall in partition max. Anything which does not fall into this partition will get into this others. Okay. So create a table. So I should have a table called range part. Do you see this runtime information? So range order date. So if you go to range order date, if you expand this, you see 1, 2, and 1 is for the date range. Look at this. From 1st of to till June, and then there's one more equivalent to 15 July. There's one more for others. And if you see, the row count is 0 because I've not done any inserts on this table. Let's say I do some inserts on the table. I have some. If you see this, see there's 2 records into this, 1 record into this, and 3 records into this because of my database. There's 1 record in 1st of Jan and March. These 2 will get into what? The partition 1, which is in the range. This is in July 15, so it gets a second partition. All these 3, July 15, July 15, all these will go into partition equivalent to 15 July. And this is in 2000, sorry. This is all 2016. This all will go into third partition, max. And same we can also have partitioning on month-wise also. Look at this. I've got, so I've got date. Based on the date, I'm going to derive month and specify it now. Look at this. So I'm saying I've got order date, but from the date I would like to derive month and then do partitioning on it. So partition by range, I'll say I'm using what? Month of order date. So I'm using a function, SQL function, say month of date will give me month bus. So I'm saying, so partition from 1st of Jan 2015 to July, June, and then equal to July is 1 and others is 1. This date will have DDMM, so now I want to derive only year and month, so I'm saying month of that, then use it for partitions. If you want to go year wise, then year of date is partitioning. Actually, when it is to improve the performance of the reading also, and it improves performance of merging, it improves performance of reading also. When you have the partitions done, so it does not go scan through entire partition, just picks from that partition then comes up. Partitioning always improves. Which one? Which one? This is for improving your read performance on the table. So this is how you can do it on the month wise. No, these are like partitioning in cube. If you say range part month, open definition of this, and then this. See, it takes from month from Jan to June and July and others. Even if I don't have to insert, even if insert, the corresponding data will go and sit in the corresponding partitions. And you can also use alter state. Let's say now you already created partitions till July. Next month comes, I would like to add partition, merge partitions. You can do that. You can say alter table, add partition, alter table, merge partition, alter table, delete partition, drop partition also can be done. You can add new partition, merge partitions can also be done with alter statements. Okay. Yeah, అంతే కదా. And one more, see, can I do range partitioning on? Mm, 1 second. 001. I'm just creating a table normally. So I got range part 00. Can I do range partitioning through UI also? Yes. I right click on the tables and say show table distribution. Mine was range 001. Select this, right click, partition table. Yeah. So I want to go with what? Range partitioning. So next. Now you can start. What is the column you would like to use for range partitioning? Order date. You like say year of or what? Month of. Year of, sorry. Year of just easy. Add partition 1 2000 2005 6 14, and I want one more single value. At intervals ఇచ్చుకోవచ్చు, single value ఇచ్చుకోవచ్చు, anything you want. ఏంటి? So if I go to this partition, open definition. So, okay. So you can equally create this with UI also. Panel next. Go to, and then if I go to this, 1 second. If I go to this now, you get now, once the partitions are created on the table, now when in the context, now you start getting off like merge partitions. Which partitions you want to merge, and then you can do it. And everything is merged again like that. Yeah, what is it? And then there's one more round robin, but this you cannot do with UI because this is not for partitioning data like anything. You would put the data across partitions based on whether the old data or the new data what is loaded. But this is what we'll be using for the fact table of your info fields. Yeah. If you have some operations, makes sense, but so I have a table. See, we use this round robin partition also to distribute the data because the size of the table is huge and you would like to distribute this size to multiple partitions. But it does not distribute the data equally. The old data, what is already loaded, it will store in one partition. And what are the new set of records you load, it will be putting into a new partition. Semantical, some inventory ఉంది. Initial stock అంతా ఒక partition like కావాలి. I want movements into one partition. I would like to distribute that way. Then I can use round robin. You will create 4 partitions first. Programmatically, you will be using, okay, I'll store this data into this block. I'll store this set of data into this block. Because I don't want my system to decide which data should go into which partition bus. At the application level, I would like to explicitly control, okay, this data should be in partition number 1, this data should be in partition number 2 bus. As it is, I'll create 4 partitions or 10 partitions bus. In the programming, I would like to control, okay, this kind of data, yes, you put in partition number 1. And this kind of data you put into partition number 2. This kind of data you put into partition number 2. I want my application to leverage those partitions depending on the requirement. For example, if you look at cube, so I deal with inventory, it says when you load initial stock with the BX, it will put into partition number 3. Sorry, partition number 2. If you load movements, it will put into 3. What application handle చేస్తుంటారు. Your ABAP programming will be handling which data should be put into which partition. You just create round robin, that's it. Like this. Partition by round robin and number of partitions what you want. And you cannot create this with UI. This has to be done with programmatically. Partitions by round robin. Check network connection. Connection to database server. Okay. We'll run this tomorrow, that's fine. Like this, you have three types of partitions: hash, range, and round robin. But there's one more point about multi-level partitioning also can be done. But you will see that tomorrow. Multi-level means I would like to mix up both range and hash first. Initially, I would like to split my data across 4 servers. So I'll do hash. Now within each server, again, I would like to do range partitioning. So I can also go with multi-level partitioning also. We'll see that tomorrow. Yeah, I'll share those text. Yeah, I'll share those text files. Yeah. Yeah, we have class tomorrow. It will be from 7 to 10. It will be 7 to 10 tomorrow. Yeah.